Okay, so you should see that recording coming up. So we were just, kind of beginning with our, basic terminology, some terminology that you could, get comfortable with because, obviously we're going to be using this as we move forward with the course. So we had talked about just, what the standard form of your angle look like. Basically the standard position would be where your initial side, especially on the rectangular grid, falls on that positive x-axis, and then you always go counter clockwise direction. When we're talking about positive angles, if you change that direction and you go clockwise, so you will see in this image over here, the way we have this, your initial side, and then we're going in the counterclockwise direction. So this would be a positive angle. Now, keeping the same initial side and terminal side, but if you go in the clockwise direction, so if you were going in the clockwise direction, then your angle would become negative. So that's something to always keep track of. So, we had kind of just started about talking about this. We talked a little bit about coterminal, and coterminal basically means you are sharing the same initial and the terminal side on each angle. So as you will see on these two images on the right-hand side, you've got just one single angle, and you can see the initial side and terminal side. But then going on the clockwise and counterclockwise directions, that actually ends up giving us two angle measurements, and that's of course going to be your positive and negative angle. So they make your coterminal angles. The other thing we had talked about was, same angle, design. You can see the initial and the terminal side, and you're actually still going in the same direction. The only difference is you've got your one angle over here, which is alpha, and then continuing in that same direction, but you make, one entire circle, and you end up back at the terminal side, and that also ends up giving you two coterminal angles. So you can have positive and negative angles, or you can basically end up with two positive, or for that matter, you can also have two negative angles directly. So that's your coterminal. So just remember the direction of the angles is really important. And that is something you will see questions in your homework assignment for this. For some reason, I don't know why my laptop is doing this. It's not done this. Maybe it still thinks it's on vacation mode. I'm not entirely sure why it's doing this. Come on, buddy. Because it seems to be having trouble processing and moving over to the next screen. Let me see if I can. Close this out. Alrighty, so the other thing we had also talked about was the radian measurement and degree measurement. So, the angles can be listed in either one of those. And, normally we do actually tend to use the radian measurement more than the degree, but you will see we kind of go back and forth between the two measurements over here. So we had gone over the definitions for this. Basically the idea is if your arc length is going to be the same length as your radius, that's what we call as the 1 radian measurement of your central angle. And, of course, the central angle is where we're talking about, the vertex of your angle is basically going to be at the origin of your coordinate plane. So you will see right here is where that vertex of your angle is going to be right on top of the center of our coordinate plane. Stop doing that, buddy. Okay, I'm going to try and see if it will let me write on the screen so I can show you what I'm pointing at. For some reason, Zoom and Adobe don't want to seem to work with each other, because every time I turn on Adobe, it's creating this problem. Okay, so the central angle that I'm talking about is basically where your angle falls right here, on the center of your circle, the center for the coordinate system. So that's where the vertex should be. And, of course, from the vertex, you calculate your central angle. So you've got your radian measurements. Now, remember, we had gone over this, you can basically take an entire circle and it's going to be just a little over 6, radians, because the entire circle is considered as an angle of 2 pi. And, pi is 3.14. So 3.14 times 2 will give you 6.28. So that's, like I said, just a little over 6 radians of angle measurement. And then we also talked about, depending on how many revolutions you go around the circle, you can kind of calculate your angle measurement. And then, of course, based on your quadrants, you can kind of know, what angles are going to fall under quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So just kind of remember that you are looking at the entire circle starting from the initial side. And remember, your initial side is going to be right here. So this is, by default, our initial side. We are always going in the counterclockwise direction. So that's how you would be coming up back to that starting point. And when you make that entire circle, that's when you are looking at 2 pi. So basically going from 0 to 90 degrees, which happens to be, pi halves, any angle that forms between 0 and pi halves, but not including 0 and not including pi over 2, is going to be your quadrant 1, right? So in that same way, from pi halves to pi, which in this case, pi is equivalent to 180 degrees, you are looking at quadrant 2. So anything in between that. Then from 180 degrees to 270, which is 3 pi over 2, is quadrant 3. And then, of course, from 270, if you go back to the starting point, 0, after an entire circle, you will now be at 360 degrees. So that's your quadrant 4. So that's kind of how you are looking at, these quadrants and then the angle measurements in this. And, as you keep practicing and working forward, you will actually start remembering these angle measurements. But while you're working and you don't remember, you have that unit circle image available in D2L. You can use that to help you out, while you're getting comfortable with these. So we had talked about how you can find coterminal angles. And, basically, like I said, you can go in the clockwise and counterclockwise direction to get your positive and negative angles. You can also go in the same direction and just, make a full circle and then come back to the terminal side. And you can get, in the same direction, you can get 2 angles that way also. So looking at these examples that we have here, they're saying, okay, so you have a positive angle, 13 pi over 6. And, if you look at 13 pi over 6, this is an angle which is actually larger than an entire circle, because just again, look at this as a fraction. So if you have 13 pi over 6, 6 goes into 12 evenly. So I can honestly break this down into 12 pi plus, 1 pi. 12 plus 1 is 13. And then, divide both of these by 6. So you can see 6 goes into 12 2 times, which comes out to be 2 pi. That's an entire circle. So if I subtract an entire circle from this, it will basically bring me back to the same angle, just shy of that one whole turn around the circle, and you end up with pi over 6. So basically the idea is 13 pi over 6 and pi over 6 are actually coterminal angles. And this would be a situation where, what we saw on that right-hand side. So this would be a situation where it's this this little diagram over here, because that means you've gone around, a full circle. So that's kind of what we're doing in that example, is going in the same direction, but you're just subtracting that one entire circle you did to come up with the coterminal angle. For the other one, so you can see in this image right over here how we went that whole entire circle. Now, if you have a negative angle, so you can see we have negative 2 pi over 3. And this one, of course, means when you see a negative, you are actually going in the clockwise direction. So that's actually this angle right over here, which is negative 2 pi over 3. So instead of going clockwise, if you go counterclockwise, you're basically looking at the coterminal angle, just going from the different direction. So in this one, again, you will see we took negative 2 pi over 3, and you actually added 2 pi on that. Because you have a negative 2 pi there, that's a negative angle. When I add that negative angle with 2 pi, you actually end up automatically subtracting the two numbers, and that ends up giving you whatever this other coterminal angle is going in the other direction. So you end up with 4 pi over 3 as your answer in this case. So you can go in the same direction, or you can go in the opposite direction and come up with coterminal angle. So you should be able to use either one of these examples to help you out come up with the coterminal angles. So let's see if we can actually pick up an example from our textbook here. I'm actually going to go back to my home page, go into our ebook. I'm just going to pick an example from our textbook over here. Just go under section 1.1 and pick an example. So we're trying to find coterminal angles, and you will see we've actually got some examples here where they're asking you to identify which quadrant do you think your angles are going to fall into, and those kind of things. So it's a good practice to kind of look at some of these examples, but let's get into our coterminal angle question over here. So you can see they're saying determine the two coterminal angles. One of them should be positive and one should be negative for each angle. So we'll start with number 15, and we'll do let's do part B, since we already actually did pi over 6. If you go in the same direction, you can take that pi over 6 and just add a circle to it. So just add 2 pi, which means you went in the same direction. And this will lead you at 13 pi over 6, because this is the exact same angle you looked at right over here in part A of your handout and example in the handout. So that's going to be your positive angle. Now, if we wanted to get an equivalent negative angle, right? Because 13 pi over 6 is a positive angle. Now, if you wanted a negative angle, and I'm just going to do a rough sketch over here. So pi over 6 is going to be, in that first quadrant. So you can see pi over 6 is going to be this small angle over here. So just, rough sketch over here. This is kind of what that pi over 6 will look like. So when you did the 13 pi over 6, that was, of course, where we went that entire circle to create 13 pi over 6. Now, if we are interested in finding a negative equivalent for this, since you are going in the counterclockwise direction here, we can go in the clockwise direction to find our negative angle. So this is where, what I would suggest to do is taking pi over 6 and subtracting 2 pi from it, and then see what your negative angle comes out to be. So, simple algebra fraction solving, that's what I recommend over here. So start by thinking about this 2 pi as 2 pi over 1. And then remember how with fractions, we always find our common denominator. So that's the same process we're going to do here. So since I have my denominator as 1 and I need my common denominator to be 6, multiply this fraction over here by 6 on the numerator and denominator. Pi over 6 will stay the same. 2 times 6, of course, is 12. So you have 12 pi over 6, and now you are subtracting. So keeping that common denominator, you've got 1 pi minus 12 pi, which will, of course, end up giving us negative 11 pi over 6, and that can be our negative coterminal angle over here. And, you know, of course, you can see, and since this is an odd number problem, you will see answers for these. So you can see 13 pi over 6 becomes our positive coterminal. Negative 11 pi over 6 will become our negative coterminal. So honestly, guys, sometimes it can literally just be adding or subtracting 2 pi to come up with your coterminal angles. If your angle is large enough, sometimes you may actually have to add 4 pi or subtract 4 pi. So that means you're going around twice. And that's the thing with coterminal angles. You can go around and circle as many times as you like. Melanie, go ahead.
Yeah, I just have a question. That's what I think it's number 9 on the homework. And I don't know if I was doing it incorrectly because I was subtracting the 2 pi and adding the 2 pi, but I couldn't submit a negative answer, if that makes sense. I don't know if that.
Do you remember what your original angle was? Because, you know, everybody's going to have a different number on that.
Yeah, so it was 5 pi over 6, and you had to find the coterminal angles for that one.
Okay.
It was positive 5 pi over 6 instead of negative.
Okay, positive 5 pi over 6. We can take a look at that. Let me just go ahead and save this very quickly. Okay, so before we get to Melanie's question, let's go ahead and take a look at part B over here. So your original angle is negative 5 pi over 6. And again, if we put this on a grid over here, negative 5 pi over 6. Let me show you how you can find out where it's going to be. So we'll go under chapter 1. And remember, this is where I have the unit circle available for you guys. So just click on that unit circle. Okay, let's clear this out for now. So you will see our positive 5 pi over 6 is right over here. And this is when you are going in the counterclockwise direction. So that's your 5 pi over 6. So if you did that same movement, but going in the clockwise direction, so you can see that would mean you would have to go this way, and your negative 5 pi over 6 would actually be at this angle over here. So your negative 5 pi over 6 is actually right here at 210 degrees. But, you know, this is, of course, going in the negative direction. So technically, it's not 210 degrees. It's going to be negative 150 degrees. So, you know, that's basically what's happening is you're just going in the clockwise direction. So this is the angle you are looking at. So that kind of should help you at least know where on the grid or in the unit circle where this angle falls. So I'm going to go back to our example over here. So again, this is part B, negative 5 pi over 6. And that's going to be about this angle over here. Okay. So again, to find your positive coterminal angle, I would actually just go in this direction since this is already negative 5 pi over 6. You know, if you go in the counterclockwise direction, you'll get a positive angle. So this is where I would suggest adding 2 pi to this, and that will give you your positive angle. So can anybody tell me what this answer will come out to be when I add 2 pi to our negative 5 pi over 6?
Would be 7 pi over 6.
It should be 7 pi over 6, yeah. So again, you know, you can do the common denominator calculation I showed you, or of course, even looking at the unit circle, you can get an idea. So you've got negative 5 pi over 6, and to that we are adding basically 12 pi over 6 when you do that 2 pi. 12 minus 5 will end up giving you 7 pi over 6. So that's going to be our positive coterminal angle. Now to find the negative one, as you can see, adding 2 pi, or for that matter, adding 4 pi also is not going to solve this problem, because you will just be going in that positive direction. So what do you think we can do to find a negative coterminal angle over here?
You subtract 2 pi.
Yeah, so when positive doesn't work, try subtracting. So start by subtracting 2 pi, which of course will also lead you to, when you find that common denominator, 2 pi will end up becoming 12 pi over 6, but this time you are subtracting. So can you tell me what this guy will come out to be?
Negative 17 over 6.
Yeah, negative 17 pi over 6. So those will be your positive and negative, because what's happening when you subtract the negative 2 pi, you're basically going in the clockwise direction, but of course you are coming and making a full circle around it, but you're still going in that negative direction. So that's why you end up getting negative 17 pi over 6. Okay, so let's clear this out. And of course you can check your answers since these are odd number problems. Okay, so Melanie, you said you had 5 pi over 6. And because my screen is not cooperating, I'm just going to use a whiteboard over here. So you've got 5 pi over 6 is what you said. And as you saw in our unit circle, that's going to be the angle right over here. So in this case, guys, since this is already a positive angle, what can we do to find a positive coterminal for this?
Add 2 pi.
Yeah, just add 2 pi, because you're going a full circle around this angle, which of course then comes out to be 5 pi plus 12 pi, and both of them are over 6. So this, as you can see, 5 plus 12 will end up giving us 17 pi over 6. And you can see this kind of mirrors the example we just did with the difference of that negative sign, because what happened here is you went in the counterclockwise direction, but of course you made a full circle and then came back to that terminal side. So this is your positive angle. Now for the negative one, what can we do? Because that means you're finding in the clockwise direction. So you're actually trying to find what this angle should be here. So what should we do?
You just subtract 2 pi, right?
Yeah, and Melanie, you said that's where you had trouble when you were trying to subtract 2 pi?
No, so I got negative 7 pi over 6, but when I submit the answer on the homework, I to put the positive and negative, it said it was incorrect, and so then it just took the positive answer, if that makes sense.
So it didn't accept your negative 7 pi over 6?
No, and also when we go into degrees, finding the coterminal, adding 360 and subtracting, it didn't accept the negative when you subtract 360, if that makes sense, for that problem as well.
Yeah. That's interesting. Because if you again look at the unit circle, and let's go back to our unit circle here, right over here. Yeah, so you can see, when you're talking about positive 5 pi over 6, oh, sorry, didn't mean to do that. When we're talking about positive 5 pi over 6, and on the other side, you will see that is 7 pi over 6. So when you're going even in the counterclockwise direction, this guy will be equivalent to negative 7 pi over 6. So I'm surprised why WebAssign did accept that answer. I'll go in and check specific to you, Melanie, and I'll see what trouble is going on, because I can see each student's response also, and I'll let you know if I find some error or something. How did you type your pi in?
I put 7, and I have you can also like type in the word like P or the letters PI and it pops up, or
Yeah.
you can find it as well. And I just put in, yeah, so I put in 7 pi and as a fraction as well.
Okay, because they do have a menu option that pops up with these symbols also. So yeah, you can either type in the word pi or you have the option. So if you did that, then I'm not sure why it didn't accept your answer. But like I said, I will definitely go back in and check and see why you were unable to do that.
Okay, thank you.
You're welcome. Here are a couple more examples, and this is just from your textbook. So if you look through the video lecture, guys, you will see the answers to these. You've got PDF files of the work that I did and also the video lecture. So I would definitely use this as a resource for examples. Now, one of the other things that we also, work with when we're talking about angles is complementary and supplementary angles over here. So here, when we're talking about complementary, the idea is that two angles have to add up to 90 degrees, or, as an equivalent to 90 degrees would be pi halves. So if the two angles add up to pi halves, then that's complementary. And then of course, if the two angles add up to 180 degrees or pi, then that's going to be supplementary angles. So one thing you always have to keep in mind, if the angle they give you is going to be so large that it's going to be greater than 90 degrees or greater than 180 degrees, then you may not actually have a supplementary or a complementary angle for those. So, just kind of keep that in mind, that not all angles will have the supplementary and complementary pair. You just have to see what the measurement of the angle is, and then based on that, you can calculate. So if you look at these examples over here, you will see we're talking about finding the complement for 2 pi over 5. And as you can see, this is not very large. You are able to take pi halves and subtract 2 pi over 5 from it. And then, as you go from that calculation, you are able to find your complementary angle. So we took pi halves because that's your 90 degrees. So pi halves minus 2 pi over 5, and then we were able to find a complementary. For that same angle, if you take pi minus 2 pi over 5, which is, pi again is the 180 degrees. So you're finding the supplement. And you can see we are able to find the supplementary angle for that. However, if you look at part B, this time your angle measurement is 4 pi over 5. And 4 pi over 5 is an angle measurement which is larger than 90 degrees or pi half. So that's why this guy has no complement. So keep that in mind as you're going through these examples. And then, of course, 4 pi over 5 is still smaller than pi. So you are able to do pi minus 4 pi over 5 and find a a supplementary angle. So that's one thing you really have to be careful about as you're finding these complementary and supplementary angles. So let's pick up an example here from our textbook again. And let's start with number 17 here. So you've got pi over 12. So, of course, that means you are doing 12 revolutions around your circle. And so when we're talking about pi over 12, where do you think that angle is going to fall into? Is that going to be smaller than 90 degrees or larger than 90 degrees? Because you can see where pi over 6 is in this unit circle. So where do you think pi over 12 will fall? Because how do you come up with pi over 12? If I take pi over 6 and I divide it by 2, which is actually the same thing if I take pi over 6 and multiply it by a half, right? Because we're taking its half. 6 times 2 gives you 12. So actually pi over 12 is going to be halfway between 0 and pi over 6. Does that make sense, guys? Okay, so as you can see, this is a small enough angle that we should be able to find both complement and supplements for this angle. So let's go ahead and take a look at this. I'm going to have to erase this. Let's come back over here. Alrighty, so to find the complement, you will take pi halves and subtract pi over 12 from it. To find the supplement, of course, we take pi and subtract pi over 12 from it. So same thing, you need to find your common denominator. So as you can see, you've got 2 and 12. So your common denominator, is going to be the larger denominator. That's the easiest way to think about it. And if the largest doesn't work, because if you have two numbers that have nothing in common, then, of course, you want to go through the process. But in this case, I know I can just multiply that first fraction by 6 and change my denominator to a 12. So you can get 6 pi over 12 minus pi over 12. And of course, 6 minus 1 will give you 5 pi over 12. So literally just fraction solving. And think of pi as, how we work with x's and y's. Even though it's technically a number here, it really doesn't have a lot of bearing on our calculation. So you just carry forward that pi as you do your calculations. Especially in these examples over here. Now for the supplement, since your pi is by itself, you can do that as pi over 1. Same thing, find your common denominator, multiply by 12. So you'll end up with 12 pi over 12 minus pi over 12. When you have that common denominator, then go ahead and subtract your numerators. 12 minus 1 will give you 11 pi over 12. So just figure out, if your angle is going to be larger than 90 degrees or 180 degrees. If that's the case, then, the complement and supplement may not be available. But if it's a small enough angle, then you should be able to find both of them. So I'm actually going to go ahead and clear this out. And you can check your answer over here. So 5 pi over 12, 11 pi over 12, as we expected. Now, when you think about 11 pi over 12, where do you think this angle will fall? Is it larger than pi halves? So 11 pi over 12.
Definitely larger than pi halves.
Yeah, it's definitely going to be larger because remember 12 pi over 12 is same as pi because, of course, 12 cancels out, leaves you with 12 with pi. So that means you are looking at pi over here. And that's one section, pi over 12 missing. So when you're talking about 11 pi over 12, oops, that's actually going to be from the initial side to the terminal side. That's what your 11 pi over 12 is going to look like. So as you can see, this is an angle larger than pi halves or 90 degrees. So this is definitely an example where you are not going to have a complement. So there will be no complement for this angle. You're just going to find the supplement in this case. So let's clear this out. We'll go back here. So this is part B. Since this is greater than pi halves, we have no complement. And then for the supplement, Can you tell me what the supplement will come out to be for this? And you guys
Is
can
it-
use, the chat to put in your answers, for pi, just use PI, or you can obviously unmute and let me know your answer. Lucy, go ahead.
1 pi over 12?
Yeah, because, again, if you multiply this by 12, you will end up with 12 pi. And then, of course, this guy is 11 pi, which will end up giving you just pi over 12, because it's going to be that little section, that you're left behind when you get to that angle for pi. So just a small section of pi over 12 will be left behind. So that's going to be your supplement. You will also see examples like number 19 in your homework. Let me go ahead and save this before I move on to 19. So when you look at number 19 with the numbers 1 and 2, is that in radians or is that in degrees?
Degrees.
Degrees, Alicia? Anybody who disagrees with her?
Radian.
I think it's in radians because there's no degree symbol.
Yeah, very nice. So I'm glad, Alicia, you mentioned that, because, we don't think of radians usually when there's no pi in there. We kind of get so used to seeing pi as part of those radian angles. But as Scott mentioned, and Scott, that's a great point. You always want to look. So if this was going to be 1 degree, you always want to look for that degree symbol. And if that little tiny circle is not there, it's not in degrees, or, the words degrees, right? So either that little degree symbol or the word degree has to be there. And if it's not there, your angles are in radians. So again, keep in mind when you're working with radians, pi is approximately equivalent to 3.14. So think about, where should pi halves fall? If pi is 3.14, what is pi half? So for our 90-degree angle, should be 1.5 something. Because, 3, the half of 3 would be 1.5, and then, for 0.14. So, and, this will actually be an approximate answer also, will be 1.57. And the reason I'm asking you guys to do this is because then it will be easy for you to see, like, especially when you're working with that part A, well, do I have an angle measurement greater than 90 degrees or not? Can I find a complement or not? So since 1 is a number smaller than 1.57, you can actually find both the complement and supplement for number 19A. So in this case, you can do pi halves, -1, and I'm not sure what the rounding rules would be on this, but just looking at the rounding rules, you can do 0.57, and of course these numbers keep going, so just use the rounding rule to kind of see how far they want you to go. But you are able to find a complementary angle measurement. For the supplement, of course, supplement would be pi -1. So that, of course, will end up giving you 2.14. Or again, if you're using your calculator, then you can basically have, whatever values you end up getting after that. So this is where you definitely want to pay attention to the rounding rules for this. But that's kind of how you would end up calculating your complement and supplement when you're given numbers like, 1 or 2. Can you tell me what's going to happen for part B? What our complement and supplement will be for part B? So complementary angle and supplementary angle when your angle measurement is 2 radians. So let's start with the chat. And I would like each one of you to put what you think the complementary angle should be for 19 part B over here. All right. Melanie, I see your answer. So I'm looking for the complementary right now. If you have both the answers ready, then you can do complementary answer first and then comma supplementary answers. If you do want to share both your answers with me, put a comma between them, and the first one should be for the complementary angle, second one for the supplementary. Okay, I've got Melanie, Lucy, Katie, looks like you guys are sharing your complementary angle with me for now. Okay, Savannah, not a problem. Okay, so let's think about this. Your given angle is 2 radians. Okay, Melanie, I see your updated answer. Now, your given angle is 2 degrees. We know for a complementary angle to calculate, it has to be an angle measurement smaller than pi halves. And you can see your pi halves is approximately 1.57, and 2 is a number larger than 1.57. So since 2 is greater than 1.57, you know, it's the same thing. You will not have a complementary angle over here, because what's happening here, guys, and I'm going to go back to our unit circle here, you know, 1.57, and let me pick a different color. So 1.57, this is what we're talking about as the complementary angle. This is 1.57 right here at 90 degrees or pi halves. When you're talking about 2 radian measurement, and I'm just kind of eyeballing this, you know, maybe somewhere over here is that 2 degree angle. So you can see this guy is greater than 90 degrees. For complementary angles, you know, it's got to be somewhere over here, not outside of this. So like Melanie, you had the negative answer in there because you just did basic calculation, right? But unfortunately, this angle is beyond the 90 degree mark. So that's why we actually cannot use this angle. And that's the reason why we would end up saying there's no complement, to this angle. So there's no complement, but however, we can find a supplementary angle because supplement is at pi minus 2, and you know pi is 3.14, so we do have room for a supplementary angle. So that would, of course, like you guys came up with, will give you, you know, approximately 1.14. So just be mindful, you can't really combine a negative angle, you know, to compensate for the complement. If it's larger than that number, there's no complement. Same thing would happen with supplement. If your angle was greater than 180 degrees, then you wouldn't find a supplementary angle either. Does that kind of help out, Savannah? Yeah. And you know, it might actually come down to where you may have to do a couple of these examples to get a little bit more comfortable with them, you know, before you are able to come up with the answers. So just be mindful that we cannot do, you know, the negative, you know, to compensate for the complement or for the supplement. That's not an option available. So I know this took us a little bit of time, and with my computer issues, it's kind of taking us longer, but I just wanted to very quickly highlight that you are actually going to see same examples with degree measurements, and you can see this unit circled. How, again, if you go in the counterclockwise direction, you have all these positive angles. And then for the same ones, they will have you work on, and we'll do some examples with the conversion next time. but they are also going to have you calculate the complementary and supplementary angles. I guess I didn't include that in my handout, but in your homework assignments, you will see they will ask you to find the complementary and supplementary angles with the degree measurements also. But here's the next thing we want to do is this conversion of going back and forth between the 2-degree and radian measurements. So we'll pick that up next time, guys. What I would like you to do is, especially those of you who, it's been a while, you haven't worked with concepts from college algebra, look through chapter P. You can just open the ebook and look through chapter P, maybe work on some examples just to feel more comfortable with those concepts. And then Melanie, I'll take a look at what's happening with your homework assignments and try and help you out with that. But guys, please start working on section 1.1 homework as much as you can do on your own. And the parts that you cannot do, we'll definitely talk about those in class and help you get more comfortable with those calculations. So, it's a step-by-step process. So don't worry about if you're unable to answer all the questions, okay, at this point. So one other thing, and I know we're already over our time limit here, but one other thing I very quickly wanted to let you guys know is my mom is actually she's no longer receiving treatment, but she was diagnosed with stage 4 colon cancer last year. She's gone through chemotherapy for 1 year, and unfortunately her treatment did not work out, was not successful in, stopping the cancer from growing. So she's at the point where we had to put her in hospice care, and she's not looking good. We're not looking at a very big timeline over here. So I am actually her primary caretaker because she is still at home with us. She's being kept at home with us, but she is transitioning. She is not doing well. So her needs are, where she's more and more dependent on me. She's unable to do anything on her own. So there may be a time where I might have to, step back, take care of my mom, and I may not be able to keep up with my classwork. So I have talked to my chair. She will work with you guys and substitute for me, if the time comes and I need to take a break. But I just kind of wanted to give you a heads up. You will sometimes see that I am replying back to your emails at like midnight or 2 in the morning, because if I'm working with her and I'm with her all day long and I'm unable to answer my emails, that I'm usually staying up when she's asleep and working on stuff. So some of my response time may be actually a little later than normal, just because I'm having to navigate around her and her needs. So just kind of keep that in mind. Don't think that I'm ignoring you or ignoring your emails. It just kind of depends on how she's doing and how much I need to do. We're constantly having nurses stopping by to check on her, do some basic care for her and that kind of thing. So a lot of times, people are in and out of the house. So I'm having to kind of work with them as they are here. So it's just a little, there's no routine to my life right now. I sometimes take a shower at midnight because I don't have time to take shower during the day. So it's really, really crazy right now. And I really just wanted to let you guys know what's going on at my end. So you didn't think that I was, ignoring you or not replying to you on purpose. It's just maybe I haven't had a chance to check my email. So that's kind of what I had. Scott, thank you very much. And I'm really sorry about your loss as well. I know how hard it is to kind of go through that. So, send me an email. Don't hesitate to reach out. I will find time and I will definitely reply back. It just may be a little bit longer than normally expected, but I am here for you guys. If I was not going to be able to keep up with my classes, I would not have started teaching these classes. So I intend to be here and working with you, but there just might be a week or two where I may not be available, okay? All right, guys, so have a wonderful evening. Don't hesitate to email me for anything you need help with, and I will see you on Wednesday evening. So have a wonderful day, guys. Be careful. Take care. And Scott, I will reply back to you on chat. Just give me a second.
Okay. Sure.
Take care, everyone. And I do appreciate that, Scott. That's very kind of you. Thank you.
You're welcome. It's
Thank you. That's very sweet of you. Thank you so much. Take care, and I'll see you on Wednesday.
Yep, I'll see you Wednesday.
Bye-bye.